Good morning.
Good morning, sir.
Right here, we are going to start today's lesson. Can you hear me clearly?
Yes, sir.
Right, okay. Before moving to the today's lesson, we should need to discuss something about we did last week. We should want to discuss some past paper questions. Therefore, I am going to do that, sharing a presentation. Right, look at the presentation here. Right. Last week we discussed about transmission media. Under transmission media, we identified transmission media as a transmission data from the medium we are using to transfer data from one location to another location. Right. This medium may be a wire medium or a wireless medium. Based on that wire or wireless, we identified this medium as a guided and unguided medium. Guided medium, wire or physical existence there, but wireless you can't find any physical existence, only they are using signals to travel data from one location to another location. Right. Then for example, we discussed some examples regarding guided media, especially guided media. We discussed in detail about twisted pair cables, coaxial and fiber optics cable. Then also we identified the unguided media examples for unguided media. That is about radio waves, satellite, infrared, like that. Only we identified the name, still not discussed in detail about the unguided media. Right. The today's lesson actually regarding this unguided media. Before that, see some past paper questions. Look at the question here. This one, 2019 business system paper. Question number 1, part 4. Briefly explain guided and unguided media by giving 2 examples for each. Right? They allocate 8 marks for this question. Only they are asking to explain guided and unguided media. Guided and unguided. Here we should mention clearly the difference between these two. Guided media, actually they have a physical existence, right? But unguided media, they have no any physical existence, only they are using signals to travel from one location to another location. That's the main difference between these two. You want to give in this difference with examples that already mentioned some example for guided media, coaxial cables, twisted pair, fiber optics in that way. Examples for unguided media, radio waves, microwaves, satellite, those are some examples for unguided media. That's the things only you want to mention for these questions. They are not asking detail about the examples. No need to explain what is twisted pair, what is coaxial cable. They are not asking in details of these examples. Only they want to difference between guided and unguided media. Is it clear? Please tell me the things are clear or not.
Yes, sir. Clear.
Yes or no, right? At least yes or no, you want to give me responses for my questions, then that will support me to continue the lesson, right? Therefore, when I am asking the question, that last time also I am giving this instruction to you. When I asking the question, please at least giving responses as yes or no. Right, look at the answer for this question. Here explaining guided and unguided. Guided media transmitted data travels through cabling system that has fixed path. Right? Here giving some example, copper wires, fiber optics wires, and so on. Then unguided, transmitted data travels through space in the form of electromagnetic signals. Right, here there are some examples also given here. Right, then write down the answer for this question. I will give you 2 minutes to complete that. Right, write down the answer.
Excuse me, sir. We can't see.
Can you see now? Can you see now?
Yes, sir. Can see.
Okay.
Yes, sir.
Okay, complete it now. Complete it. Right, okay, then I think you finished writing the answer for this question. Move to another question. Look at the question here, this one, 2018, question number 3, part 1. They're asking, write a short notes on the following topics. Write short notes. Twisted pair cables and fiber optics cables. Part A, twisted pair. Part B, fiber optics. Right. They allocate 4 marks for the both question, one each 2 marks. And here you want to give in a small description about twisted pair and fiber optics. Already we learned what is twisted pair and fiber optics. Both of these cables are example for guided medium. Right? From that point, you can start start writing the example answer. Twisted pair is an example for guided medium. They are using copper wires insulated with each other, especially used for small established small networks within a room or within a building. It's more suitable. Right? In that way, you can explain some features about the twisted pair. This twisted pair comes in two categories: unshielded twisted pair and shield twisted pair. Especially shield twisted pair protect to electromagnetic fields, external electromagnetic fields. Right? That type of description we expect from this question. Right, then fiber optics, similarly you can explain. That's the most expensive one, but when regarding the data rate, fiber optics are the highest data rate available under guided medium. That fiber optics are made up with glass strands. Right, the appearance of these glass strands that last week I showed about this fiber optics. This to make by glass strands. Therefore, this glass strands make up using the concept, optical concept. Therefore, their speed is similar to light speed. Right? Look at the answer here. Twisted pair and fiber optics. That first paragraph says about twisted pair cables. Only 4 or 5 lines need for this description. Here, no need to separately describe what is UTP, what is STP. Both commonly you can identify it as twisted pair. Look at the answer here. Especially you need to mention the things I highlighted in black color. These points you need to mention in your answer. The first line says how made up. Made up using copper wires insulating them each other. Then you can say about cost. It's very popular due to its low price. Then you can say something about their usage, especially used for telephone, to connect telephone, your home telephone with the receiver. And also they are using for small networks, to establish built up small networks. Then in one line you can say something about limitations of this type of cable: low speed and unprotected to external electric fields. For the fiber optics also you can explain similar features, how made up using a strand of glass. Signal traveling speed is similar to light. Then there are some usage, especially used for external cabling to establish large network. Example, wide area network. Right. Complete. Right, okay, I think you finished writing this one. Then we'll move to another question. Look at the question here. This one, 2016, question number 4. Question number 1, part 4. Discuss 2 applications of data communication. We already learned about what is data communication. They are asking in this question, they are asking the applications of data communication. Right? This data communication system, what are the places, what are the applications use this type of data communication system. Currently we know this data communication system use most of organizations, educational institute, almost all the organization, large organization use this data communication system. Right? For example, banking system. Right? They are using this data communication to do various type of transactions, especially consider about the internet transactions, internet banking. That's one example of data communication, application of data communication. Right? If you want to see the balance of your account, or if you want to transfer your money from one account to another account, all of this can be happen due to this development of data communication. Right? Not only in banking, there are another example. Think about airline reservation. Right? Airline reservation, they are issuing tickets, reserving seats. Right? Then the customers can reserve seat from anywhere in the world. That type of facilities they are given due to use of this data communication systems. Then think about the business organization. There are many large and medium type business organization spread throughout the world. They want to maintain proper communication between within the people in the organization as well the external people. Right? To how they are maintaining this communication. They are using data communication systems to maintain this type of relationship between the people within the organization and the external, the people externally. Right. Therefore, data communication system is very important for various types of applications. And no need to describe many applications, only they are asking 2 applications regarding the data communication. Right. Look at the answer here. In this answer, explain about 3 data communication systems. Only it is okay to describe 2 applications of data communication. Right. However, write down this example, this application example answer. It contains 3 applications. Write down all of these 3. First one, banking. They are giving some operation under banking data communication systems. Money transfer from one account to another. Bill payment, transaction from debit or credit card, internet banking. All of these things happen due to the development of this data communication system. Right. Then airline, another example. Customers can reserve their seats, or they can pay money for their tickets through this data communication systems. Right. Then last example, business organization, they are using data communication system for mainly for maintaining proper communication between different levels of managers and the customers as well. Right. Write down the answer here. Right. Okay. I think you finished writing this answer. Is it clear? These points?
Yes, sir.
Okay. Please response. Please give your feedback. Right. Other students also giving the feedback. Only one student always communication with me. Please giving answers, feedback for others also. Right. That's about the questions. That's the nature of the past paper questions. Always they are asking the essay type questions, right? You have to remember and write down. Remember and write down, right? Therefore, whatever the things we are doing in the classroom is very important. You have to remember the things and write down. Therefore, it is easy if you follow the lectures all the time, then it will be easy to write down the answers. Right, okay, that's enough for this time. We'll move to the today's lesson. Transmission media 2. Can you see the screen here?
Yes, sir.
Right. Okay. Then before we move into the unguided media, look at the table here. That's actually the last screen, last slide of the last week lesson. That last time we didn't discuss about this one. This is actually a comparison of 3 cables: twisted pair, coaxial cable, and fiber optics. Here, this description given under 5 features. The features you can identify the signal transmission, external magnetic field, bandwidth, installation, and attenuation. Signal transmission says how signal transmission through twisted pair, coaxial cable, and fiber optics. If you consider the twisted pair part, signal transmission happening through a metallic conducting wire. Metallic conducting wire. Under coaxial cable, it happened through a inner conductor of cable. Inner conductor of cable. Right? Please look at the last week lecture, then you will understand what is inner conductor, what is metallic conducting wires, right? The picture of all of these cables I gave last time. If you are not remember, you can refer the last time lecture. Then if you consider the fiber optics, their transmission media is optical form over glass fiber. Glass fiber is the signal transmission medium. Then regarding the external magnetic field, then twisted pair affected due to external magnetic field. If you consider the coaxial cable, less affected, not much as the twisted pair, but if you consider the fiber optics, they are not affected, actually not harmed from the any external magnetic field. Here, external magnetic field mean lighting or thundering. That's the things happening in nature outside the home, outside your organization. Right. Then bandwidth. Bandwidth refer to the volume of data going through a particular medium per time. That's called bandwidth. If you consider the twisted pair, it says low bandwidth. when compared with the coaxial cable and fiber optics. In the coaxial cable, it may be moderate bandwidth and fiber optics high bandwidth. Then installation, easy installation. Coaxial cable is somewhat difficult, but fiber optics are very, very difficult because outside cabling, especially cable, if you want to establish network system between cities, between province, between countries, right? That most suitable one is fiber optics. Therefore, the cabling is very difficult. Think about the cabling in country to country. Then we have to think about how to cabling undersea and undersea cabling. Then it is very difficult one. Then coaxial cable is somewhat fair because the cabling happening mostly in small areas. Twisted pair very easy. Then attenuation means the strength of signal. Last time also I explained that under properties of the signal, attenuation is one property. The reducing attenuation means reducing the strength of the signal. The twisted pair having high attenuation, that means you want to use repeaters to maintain the attenuation. They want to use repeaters. Then coaxial cable, low attenuation, fiber optics mean very low. Right. Write down this table also. I will give 2 minutes to complete that. Right. Okay. Is it clear the points up to now? Is it clear the points up to now? Can you understand the differences between these three?
Yes, sir.
Right. Okay. Then one question. Please tell me, anyone, if you want to cable, if you want to establish a network system between two buildings, that buildings are located separately, two different locations, but not far, near locations, then what's the suitable medium? If you want to establish a network system to two separate buildings, it exists, it located near, very near to each other, then what the suitable methods? Cable. Can someone tell me?
Twisted.
Twisted pair. Actually, twisted pair, when consider the some properties, in two building means it needs somewhat external cabling. Right? That means that you want to cable outside the buildings. That means it may subject to external magnetic fields. Twisted pair, normally the cable, that is the medium affected to the external magnetic field. If you are using twisted pair also okay, then which category is the most suitable? The most suitable one is STP, shield protected, shield twisted pair. Or otherwise, coaxial cable is okay. Right? That's better to face in external magnetic fields. Right. In that way, maybe there are some questions in that way also. Right? They are giving some places, then asking what are the suitable medium to establish the computer network. That type of question may be in your questions paper. Right. Okay. That's about the guided media. Right? Guided transmission media. Right. Now we'll move to unguided transmission media. Right. Unguided means no physical existence. Only they are using data signals to transmit data from one location to another location. Right. Then these signals, how travel these signals? What are the methods to travel these signals? Right. Those are the things we are going to discuss from now. Unguided media. Write down the topic. Unguided media, also known as wireless media. Wireless media. Within bracket, write down wireless media. Right. Here I am give you some description about this unguided media. Here that already I mentioned, unguided media, they have no physical medium, only they are using electromagnetic waves. Electromagnetic waves. Actually, this we have an electromagnetic spectrum. This electromagnetic spectrum says what kind of signals located in different frequencies. That frequency, that you have some idea about frequency, that last time also I explained what is frequency. Look at the diagram here, that don't start writing now, that I will give time to write down. This is called electromagnetic spectrum. This spectrum refers the frequencies from 3 kilohertz to 900 THz, mean terahertz, 900 terahertz. And within this spectrum, we can identify different types of signals. Different types of signals. Actually, if you consider the frequencies from 3 kilohertz to 300 gigahertz, right? In this diagram, this blue color area, the signals lie in this blue color area known as radio waves or microwaves. Radio waves and microwaves. Actually, some small difference between this radio wave and microwave. Both of these type of signals exist between 3 kilohertz to 300 gigahertz. Then look at the next, this yellow color area from 300 gigahertz to 400 terahertz. Right? Then signal called infrared. And above the 400 terahertz, you can find the signal called light waves. Light waves are above the 400 terahertz. Right. Then you can identify your signals according to the frequency. Now write down the this paragraph and draw the diagram. Based on this frequency spectrum, there are 3 types of unguided media. Also write down these 3 types: radio waves, microwaves, and infrared. Right. Complete it. I will give 2 minutes to complete this screen. Right, okay. I think you finished writing these things here. That's about unguided media, introducing unguided media, also known as wireless media. Here, in this case, you have to remember, you must remember unguided media special feature is no physical medium. No physical medium. That means you can't see, you can't touch it, right? No physical medium. They are using electromagnetic waves, right? In other words, signals. Right? Signals, another name for that. Electromagnetic waves to transmit data from one location to another location. One location to another location. These electromagnetic waves we can find in three ways. There are three categories. These three categories you can find in a special frequency area called electromagnetic spectrum. This frequency area in this diagram explain this frequency area. Start from 3 kilohertz. Frequencies start from 3 kilohertz. It's going up to 900 terahertz. There are three different types of electromagnetic waves exist in this electromagnetic spectrum. Right? According to the range of these frequencies, we can divide it three types of electromagnetic waves. That is called, the first one radio waves, second one microwaves, third one infrared. These radio waves and microwaves both together located within the range 3 kilohertz to 300 gigahertz. Radio waves and microwaves, these both signals you can find the range 3 to 300 area. Then infrared you can find the range between 300 to 400, 300 gigahertz to 400 terahertz. Right. In that way, you can identify the types of unguided medias. Right. Then we should want to discuss about these things in detail. We'll take one by one. The first one, radio waves. Radio waves. Then I am moving to next slide. Write down the topic, radio waves. Right. Here, radio waves, you can get the range between 3 kilohertz to 1 gigahertz. Right. Actually, again, look at the diagram here. Electromagnetic spectrum. Here, the first range you can see from 3 kilohertz to 300 gigahertz. But if you consider the radio waves only, these radio waves exist from 3 kilohertz to 1 gigahertz. 1 gigahertz. Actually, this 1 gigahertz may be in this area. In this area, only you can find radio waves from this area. Right, it's not mentioned here in this diagram. Right. Under radio waves, it says these signals exist from 3 kilohertz to 1 gigahertz. That is called radio waves. Then another feature of this radio wave is omnidirectional. Omnidirectional. Omnidirectional means the signals sent to anywhere, not these signals sent to any particular place, any direction, no directions. Right? These signals send in around all over the areas. Then you will understand it. I will show you the images of this omnidirectional mean. Omnidirectional, in that case, no need to align two antennas together. No need to align. If it exists only one antenna, around this antenna, it sends signals to any direction. The best example is radio transmission. That particular station, they are deliver the radio waves, that whatever the location in the world, they can catch up the signal. That's another good example for radio. They do not need to have aligned two antennas. Right. Here they are giving some examples: AM, FM radio, television, some application of radio waves. Right. Let's look at the diagrams here. This diagram, this is a block scattered diagram here. This one says the signal transmission happening around this antenna. It's not particular direction. It's sent to all areas around the antenna. Right? Look at the picture, this picture also, then you will get best understand of distributing the signals. They start distributing signal from a midpoint, that means the antenna, then send in the signals from antenna to the other areas, not a particular location. It's sending all over the world. Then if you have a radio, the catch-up device, if you have a signal catch-up device like a radio, then you can catch up the signals. Right. Then look at the third diagram here. These are some actual antennas. It may be a radio or television antenna. Right. That's the actual antenna that's capable of omnidirectional. These are actually omnidirectional antennas that capable of sending signals to all over the world. Right. Okay. Now you can write down the paragraph here. Only draw this first diagram. This one. Only draw this diagram here. Right. Now start writing the paragraph here. Right, I think you finished writing this one. Is it clear what is radio waves?
Yes, sir.
Right. Then what is the frequency range for radio waves?
3 kilohertz to 1 gigahertz.
Yes, correct, very good. 3 kilohertz to 1 gigahertz. Then omnidirectional mean, then you should want to know the important terms. Then I am again summarize. Omnidirectional mean sending signals to any area, any direction, not no particular direction. Omnidirectional mean no particular predefined direction. It sends signals to any direction. Then sending signals to any direction given in this picture. I give an idea about this picture. Right. Then omnidirectional antennas. How look like omnidirectional antennas? You can see in this picture here. Right. Then application, if you consider some application regarding this radio waves, especially radio, AM, FM radios, television, right? Television, like that. Right. Okay, that's about radio waves. Then move to the next type of unguided media, microwaves. Microwaves, write down the topic microwave. Microwaves exist 1 to 300 gigahertz, 1 gigahertz and 300 gigahertz. In that area, the waves exist in that area called microwaves. It says unidirectional. That's the opposite of omnidirectional. Unidirectional. That means what? Then you can get idea about what is unidirectional. You already know what is omnidirectional. The opposite of omnidirectional is unidirectional. That means in this case, if you are sending the microwave, it needs a particular location. You want to know the end location. Right? If you are the unit or entity of delivering the waves, then you should already know what is the place you are going to deliver the waves. That is unidirectional. The antennas should be aligned with each other. It needs two antennas, right? Two antennas, one for delivering or distributing the microwaves, the other for capturing the waves. Both these antennas should be aligned in one direction. Right. Need to be aligned. That's why I highlighted that word there. Then high frequency microwaves. There are sometimes you can find very high frequency microwaves. These normally microwave signals are penetrate through the wall. The penetrate means going through the walls. But the frequency is high. It will not capable of going through the walls. That's called penetrate. It cannot penetrate if the signals are very high frequencies. Right. This look at the diagrams, some diagrams here for the unidirectional antennas. Right. Before that, write down the statement here. Right, okay, then finish writing here. I think you have finished writing this one. And the microwave here, important point, it slices between 1 gigahertz to 300 gigahertz. Then you have to remember the points. Then microwaves are unidirectional. Unidirectional mean that is opposite of the omnidirectional. When unidirectional, all the antenna should need to be aligned. Then here the most suitable examples, right? When consider the example for unidirectional, right? Think about your mobile communication. It need to be aligned. The signals you are producing from one phone, then you want to go in this signal the intended phone. No, therefore that is unidirectional. Right? Communication through cellular phones are unidirectional. Then local area networks, right? Networks are unidirectional. Right? Then intended data, you want to go to the particular location. Right? Then we'll see some pictures regarding the unidirectional antennas. Look at the pictures here. That is one example. This is created using radar technology. It's a very large unidirectional antenna. Then another type of unidirectional antenna that is also radar type. Then another unidirectional antenna that's they are trying to keep it in the orbit, that means outer space of the Earth. Unidirectional antenna, they are preparing to move this antenna to the outer space using this satellite. This one satellite technology antenna, another example for unidirectional. Then another satellite type unidirectional antenna. Then again another satellite type unidirectional antenna. Right. Those are some pictures about unidirectional antennas here. Right. Then we'll see some applications of microwaves that already I mentioned this application here. In red color, I mentioned some of the popular application: cellular phones, satellite networks, and wireless LAN, local area networks. Right. These are the most popular applications of microwaves. Right. There are two types of this microwave signals are propagation or sending. The one is terrestrial microwaves, the other one is satellite microwaves. Right. That microwave signals are how sending, how propagation these signals. There are two types. One is terrestrial microwave. The second one is satellite microwave. Right. Write down this application also. Right. Okay, then I think the points are clear up to now. Is it clear up to now, the points here? Is it clear up to now?
Yes.
Right, okay. Then give the feedback for when I am asking a question, then it will support me to continue the lesson here. Then I don't know your preparation, your understanding of the lesson. Therefore, when I am asking the question, please tell me at least yes or no. I think all of you are get a clear understanding about this unguided media up to now. Right, here in this slide, we are discussing about applications of microwaves. Right, this microwave in here, they are using the unidirectional property of waves. The unidirectional mean only this data can travel to one location. If you are the person who produced the signal, then there is only one location to capture these signals. Right? Then therefore it need two antennas, one for producing, then another for capturing the signals. That's also known as unicast transmitting, or one-to-one communication. Then there are some application also you can see here. Cellular phones, satellites, and wireless LAN. These are some common example. Actually, all of these examples are wireless. Cellular phones, satellite, all of these are wireless because we are using microwaves. Right? Already we are discussing about the unguided. Unguided means without physical medium. Right. Then sending this information, sending these signals, they are using two ways. The first one is terrestrial microwave. The second one we know as satellite microwave. Then we should have a small idea about the difference between these two. The next slide will explain the difference between this terrestrial and satellite microwave. Right? We are not going in deep, but in short, we should know the difference between these two. Therefore, I am moving to the difference here. Right. First, we'll see about terrestrial microwave. This terrestrial type microwave says all the antennas should located on Earth, on the ground. Both antennas should be in the ground. Then they can start communicate with each other. Right? That here in this statement explained it. Terrestrial right? That disconnect, the connection is disconnect due to poor signal in my part. Okay, yeah, I have a problem. Yeah, I am not able to share in the screen. I think the host should move again. Right, please wait. I am solving this problem. Right here, who is Milinda Chandrasekhara? Please feedback, Milinda.
Sir?
Yeah, the host is moving to you. Please move the host to me also. Change the host. It's automatically, I don't know the reason for that. Now you are the hosting. Try to
Yes, sir. How to move, sir? I don't know how to move. I leave and come again.
You don't leave it. I think three dot blue color button in your box. Blue color button, three dotted blue color button there, the right corner, right top corner. Can you see that? In your box, there's a blue color button, three dot button. Click on it. Click on the button, then change the host to me. Right?
Sir, I didn't see the blue color button.
check your participant list. Click on the participant.
Okay, sir. Then
Then can you see the my name? Chanda Vijayakon.
yes.
My
Yes.
in that's a button more.
Yes. Make a host. Okay.
Then click on the host.
Okay, sir.
Okay, thank you. Now it is okay.
Okay, sir.
Now can you see my screen here? Can all of you see my screen? No? Can you see my screen now here? Can you
Yes,
see
sir.
the
Can see.
yes, presentation now? Okay, we are discussing about the terrestrial microwave. Right? That's the first category. Terrestrial microwave. What is happening under this transmission is all the antennas should be grounded, should be located on the ground, on the earth. Right? Then in the diagram, look at the diagram here. Then you will get clear idea about that. Earth you can find in like that. That's the ground. Then two antenna located in two places. The one antenna they are using to transmit the data. That is called transmit antenna. On the left, you can see it. On the left, located the transmit antenna. Then they are starting to transmit signal. That is called signal propagation. Then another antenna should located the right side. That is called receiving antenna. Right? That's the receiving location. Right? Only two antennas should exist in the earth. These two antennas is enough to propagation the signal from one location to another location. Right? That is called terrestrial microwave. Right? Now complete your notes here. Write down the lines and draw the diagram also. Right. Okay. I think you finish. Write down the statements and the drawing the diagrams here also. That's the first category, terrestrial microwave under microwave transmission. Then try to get an idea about the second category, that is satellite microwave. That's the one most popular. Normally, you know about the something, you have a little idea about the satellite transmission. Right, that's the second way of under microwave transmission. That's actually another picture. That's no need to draw in this one. Under terrestrial microwave, another diagram that containing additional antenna. Middle there, that's main microwave. That's the antenna start producing the signal, sending the signals. There are two antennas. One is on left and the other one is right. They are ready to capture the signals. Right? If you have the antenna aligned with the main one, then they are capable of capturing the signals. Right, that's another explanation for terrestrial microwave. Now we'll move to the next one, satellite transmission. Satellite microwave. Actually, that is happening due to a satellite. Satellite is an object revolving around the Earth. Using this satellite, there are transmission signals all over the world. For this case, there should satellite antenna located on the Earth. One antenna to produce the signals or send in the signals to satellite, then the other one they capture the signals from the satellite. In that way, they can distribute signal all over the world. Maybe it is enough 3 or 4 satellite to cover the Earth even. Right. Look at the diagram here. This explains the concept. There's a satellite that located from 22,300 miles from Earth. Actually, it is approximately 36,000 kilometers. Right, 36,000 kilometers from Earth. There is a satellite located there. In the Earth, there's a one antenna to send in the signals. That is called uplink station. Uplink station. Then another station should located another area in the Earth. That is called download link station. Downlink station. Right. In that way, they can transmit satellite signals through the world. Right. Now write down the paragraph and draw the diagram here. First, write down the lines, statements, then draw the diagram. Put the topic satellite microwave. Right, okay, then I think you finish writing and drawing the diagram here. Now look at some more diagrams and pictures about satellite microwave. Here explain another way of this concept. Here that mention the distance in kilometers, 36,000 kilometers from Earth that located the satellite. Then there's a separate dish antenna in the left side. It should their task is transmitting the signal, sending the signal to the satellite. That is called transmitting antenna. Then right side another dish that is called receiving antenna, that signal receiving from the satellite. In that way the microwave, satellite microwave transmission happening. Then another picture that's a satellite can be found on the outside the Earth orbit. Right. That's about the satellite microwave. This dish antenna located on the Earth. Right. Okay, then we'll move to the third category of unguided medium, infrared. Infrared. Right. This infrared can be found under the, when you consider the frequency spectrum, there are 300 gigahertz to 400 terahertz. In that range, this infrared can be found. This infrared especially used for the short ranges networking. Short ranges networking, especially you know, when you consider the home equipment, remote controller of your TV. That's a good example for infrared communication transmitting. That also not capable of going through the wall because of this high frequency. Right? That's why it says cannot penetrate the wall. Right? Okay, that's about the infrared transmission. Here you have to remember the frequency range. That is 300 gigahertz to 400 terahertz. Then remember this infrared you specially use for communication, wireless communication in short distances. Good example, the remote control of your TV in home TV is good example for that. Also some other short distance communication like Bluetooth communication. That's another usage of the infrared signals. That's the one picture of remote controller. Then infrared lamps are also available. They are using this infrared beams. Right. Okay, that's about the infrared signals. That's another feature is cannot penetrate the world. That cannot penetrate mean they are not able to go in through wall. Therefore, in infrared communication is one room cannot be interrupted by nearby rooms. Right. Okay, write down the paragraph here. Okay, I think you finished writing these statements here. Here about infrared, then if consider the things we discussed up to now, that's the transmission media we are discussing about. There are two types of transmission media, guided and unguided medium. All the example for guided medium we already discussed last week. Some example we can remember, twisted pair, coaxial cable, and fiber optics. Then the second part of the transmission media is unguided medium. Unguided medium, no physical existence. They are using only signals, electromagnetic waves to transmission data from one location to another location. The signal's nature is we can't touch it, or we cannot see. Only the specific medium this carry these signals from one location to another location. Right. There are three medium we identified under unguided medium. The first one radio wave, the second one microwave, then third one infrared. These three categories based on the electromagnetic spectrum. These spectrums ranges from 3 kilohertz to 400 terahertz. In between, there are these three signal type available: radio waves, microwaves, and infrared. And we already discussed these three things. Then our next part is actually in this point we are ending discussing of the transmission media. Transmission media. Right. Any problem up to now? Is it clear? Please give feedback. It is important for me. You can discuss now any problems or any experience you have in your organization or personally. If you have any experience, you can share now. Or if you have any doubts or any problems also, you can ask. Then we can share our knowledge with you. Others also comment for the ideas. At least tell me, is it clear up to now or not?
Clear, sir.
What about the others? Only one student always telling yes or no. Please give some ideas of others also.
Clear, sir.
Okay. Okay, then only I can continue the lesson. And therefore, always when I ask in the questions, please give your feedback. It's important for me. In chat box, one student says, can you share sites, our WhatsApp group? I am not clear that. Do you have a WhatsApp group? Do you have in this class? Do you have WhatsApp group?
Yes, sir.
Right. If you have a WhatsApp group, please add me for that group. My WhatsApp number I am posting in the chat box here. I think the very first day I posted it. I think you have my WhatsApp number. Then the administrator who maintain your WhatsApp group asked to add me to your group. Then I can share the links and other things for your WhatsApp group also. Right? Okay. At least like that, tell if you have anything to clear, please give me through the chat box. Right, I think many of you saying it is okay, clear. Therefore, I am moving to the next part of our lesson. Write down the topic. Data transmission modes. Data transmission mode. This data transmission mode actually explain the direction of traveling the data. Right? Direction mode. Therefore, it is also known as directional mode, or data transmission modes, also known as directional mode, because this particular session discuss the way of the direction of transmitting the data. Right. There are three types of directions we can identify. These three here. The first one says simplex, then second one half duplex, then third one full duplex. Right. In this way, we can identify three modes of data transmission. Three modes of data transmission. Right. Write down the paragraph here. That's the introducing what is data transmission mode and the three types. Right. Complete it. Right. Okay. Then we'll move to one by one. These three. This explain the direction of data transmitting from one direction to other direction. Right. The first one, that subtopic, write down simplex transmission mode. Simplex. Right. The simplex mean the transmitting happen to only one direction. Right. Suppose there are two locations. One location is each and every time produce the signal. That particular location capable of sending the signals. There is another location. That particular location is capable of capturing the signal. One location for sending, another location for capturing. But this second location, this capturing location, is not capable of sending feedbacks. Sending feedbacks again. That is called, that type of communication called simplex communication. That again, that's the one location. that particular one capable of sending or producing the signal, producing and sending. But the other location only capable of capturing the signals. That location, that second location, not capable of sending feedback, sending responses again. And that type of communication called a simplex communication. Can you tell me one example for that type of communication? There are many examples we can get from real life examples also available, or technical side examples. They are also in communication examples. Whatever the example type, that's no problem. Can someone tell me one example for that type of communication?
Television.
Television, yes, very good. Television station only they are capable of sending. That the other part, that means the users only capable of what they are saying, what they are displaying. No way to respond. When you are looking at the television, are there any way to giving responses for the display, the things displayed to the from the TV? No, only we can see it. What television saying, displaying to us, only we can see. There is no way to give it feedback. Right. That's very good. Television communication, then radio also the same type, radio communication. Those are we can categorize under simplex transmission mode. Right. Look at the diagram here. Simplex one direction. There is two computers in this diagram. One computer sending the signal to the other computer. This other computer is not capable of sending feedback. Right. Then write down and draw the diagram here. Right. Okay. Then that's about simplex transmission mode. That's also known as unidirectional. That's also correct, unidirectional, because one station is capable of sending the data, but that particular location not capable of receiving it. The other location only capable of receiving data, but not capable of sending it. And that clearly mention that things in this statement. Simplex transmission. Then we'll move to the second part, half duplex. Then write down the topic. Right. That before that, look at the diagram here also, simplex mode. Here given some additional examples. The communication through actually in the computer itself, consider the computer itself, some communication through some parts of the computer with the computer. That means the communication of keyboard and computer. That's simplex. Only we can capable of sending or typing or inputting the data to the computer. And then output will be display from another device. It may be a printer or monitor. But if you consider the keyboard and computer, that's simplex. Only capable of sending information from keyboard to computer. There is no way to giving feedback from computer to keyboard. I think it is clear for you. Similarly, mic and computer, then mouse and computer, printer and computer. All communication is one-way communication. Right? Then either input devices to computer or computer to computer from output devices. Now, extra example for simplex communication. Try to understand. It is not difficult. That's also examples for simplex communication mode. You can write down below. No need to draw this diagram. Some extra examples. In addition to television and radio examples, in addition to radio and television example, write down some more examples. Keyboard to computer, mouse to computer, printer to computer, like that. Shiromini. Right, okay. That's about simplex transmission. Now, then we'll move to the next one. Half duplex transmission. Here also half duplex, there are two stations. In this case, the both stations are capable of sending information to each other. Right? That one station is sending the information, then the other station is capable to send in feedback to the other. Right? Here the difference is only that the communication happen, but not the same time. Not the same time. That's the special feature of the half duplex. Right? Both stations are capable of sending information, but not the same time. Right? Here, that in this diagram says transmission in either direction, but not simultaneously. That's the important part. Simultaneously mean same time. Right? Then once you send in the information, then that particular station should have to wait sometimes getting the feedback from the other location. Right, here the best example is walkie-talkie. I think all of you know this small device. Normally in police stations, these policemen use this walkie-talkie device. Then internet browsing. Internet browsers also under this category, half duplex. Right? Once we once we request a website, then we have to wait sometimes to get in that particular web to your computer. That's also under half duplex. Right. Draw the diagram. Before that, write down the statements here. Then write down the examples also. Right. Complete it. Right. I think you finish writing the things. This slide here. In this slide, explain about what is half duplex. Half duplex mean both side or both station is capable of sending information, but special here is specific thing is only not in the same time. Both stations are capable of sending information, but not the same time. That's also called as semi-duplex. Semi-duplex. Right. Some example you can see below: walkie-talkie and internet browsing. Right. Then move to the third category of data transmission mode, full duplex. Full duplex. Full duplex is very similar to half duplex, but the difference is here data transmission they can do at the same time. Same time transmission is capable of both stations. That's called a full duplex. Right here, it is explained. Full duplex is the data transmission mode in which data can flow in both directions at the same time. In red color, you can see that's important when you are describing what is full duplex at the same time. Right. And examples, consider some examples here. Telephone network. Right. Telephone network is the good example for this full duplex. If you are, that means this telephone network you can use to communicate with each other in conversation nature. Right? The same time you get the feedback. Right? If you say something, the same time you get the answers from the other party. The normal smartphones on your hand, then normal your home telephone, all of these are under full duplex. Right? Here, in which both person can talk and listen to each other simultaneously. Right? That's called full duplex. Full duplex. Can you clear? Can you clear? Write down that before that. Write down the things here. Right, okay, then I think you finish writing this part here. That already I mentioned. If you are missing something to write down or anything of this lecture, you can get this lecture, recorded version of lecture again. All of the presentation and the recorded version of this lecture available in your Edmodo accounts. Go to your login to your Edmodo accounts and then visit the link. Then you will get the recorded version of this lecture. The presentations also available there. In addition to that, there are some other materials, important materials you can find on your Edmodo accounts. Also some assignments and quiz also available with your Edmodo accounts here there. Right, okay, that's about full duplex here. Is it clear up to now, this transmission mode? Is it clear up to now?
Yes, sir.
Right.
Yes, sir.
Okay. Okay, then this transmission mode, there are three types of transmission mode: simplex, half duplex, and the full duplex. Right. Then can someone tell me the normal classroom, the teaching teacher and the students, which category? simplex, half duplex, or full duplex?
Full duplex.
Yes, full duplex. At the same time, teacher and students communicate with each other. Teacher teaching the things to the students. Students can feedback to the teacher. Right, very good. That's full duplex. Then what about the teaching through these technologies? Right, then me and yourself through the Zoom technology. Then what transmission medium?
Half
Transmission mode.
duplex.
Half duplex, that one answer. Is it correct? What about the others?
Full duplex.
Yes, actually full duplex. Now, the same time, you and me, the sharing information. I am asking you question. The same time you giving the answer. That's the not difference what we are doing in the normal classroom. Right? Only you and me, not meet together, not face to face, not meeting there. But if you are on the video, me and you, then also face to face again, not physical existing, right? The virtually you and me together meet. Physically, we can't see you. You can't touch you physically, but we meet together. Same time, I am asking you question, you giving the answers. All of these things happening like a normal classroom. Therefore, this is also a good example for duplex transmission. Right, okay, that's the end of transmission mode. The next part is computer network. After the break, then I will start computer network part. Right, that's the things we should want to know under data communication. Right, then you want to know what is data communication, then the data communication system, elements of the system, then transmission media, and the transmission mode. All of this we discuss up to now. Then the next part is computer network. I am going to start it after this break here. Right, after the break, I am going to start that part. Again, I am doing the activity. This time, this activity you can you have to do it in your Edmodo accounts. Therefore, please log in to your Edmodo account as soon as possible. This Edmodo account having your activity. That I will give time to do that. Until that, you can log in to your Edmodo account. Right. Then one activity I am doing that today's before ending the today's lesson. Right. Okay. Take the break. Now I will start this lesson again 11:15. Right. 11:15. Right. Okay. Okay, I think again back to class after the break. Can you hear me? All of you can hear me?
Yes, sir.
Okay, then I'm going to start the new session, computer network. Before that, again, I want to do small activity. This is for you to talk because most of you are not talking, right? Not giving feedback. Therefore, I am do one small activity to get involve you to with the lesson. Right? Here, very small and easy one. I am asking your name, right? Then that particular student only give the answer for this question. Right? Most of you, I think here I can't see your name there, but I can see properly your index registration number. Therefore, I am asking, I am calling your registration number. Then that particular student tell the answer for that question. Right? This question will display on your screen. Then tell your answer. Then after that, it will display the correct answer. Then you will ensure that your answer is correct or not. Okay, then all of you are ready for that?
Ready, sir.
Right. Then I'm screen sharing here. Right. Can you see the screen here now?
Yes, sir. Can see.
Right. First one. This is the first question. You can read it now. The question. Yeah, it's very difficult to find your names. Only one or two students giving their names. And therefore, I'm calling you from your index registration number 120 120 120. Right here, the question: the exchange of data or message between two devices over some medium. This is called what? This is called what? 120. Please look at your screen there, then you can get your number on your registration number, last 3 digit, last 4 digit. I am calling from your last 4 digit, 0120. Right. If not, then move to another one. 125. 125. 125. Okay, no answer from that. When you are giving the answer, please unmute and giving the answer, then again mute. Right. I think you are not talking, even giving this type of questions. So, oh, anyone?
Data
Communication.
Data communication, right? We'll see that is the answer is correct or not. Yes, that's correct actually. Data communication. Very good. Right. The next question, I think you are any of you can give the answer here, right? You are not talking when even I am calling your numbers. The way in which data is transmitted from one place to another. The way in which data is transmitted from one place to another. What is called that?
Channel.
Channel. Any other answers? One student say channel. Good try. We'll see that answer is correct or not. You have another chance. Another student. Is there any other answers? Right, we'll see that the answer is correct or not. Data transmission. Data transmission. Right, next one. This is the question. Actually, it is displayed in very small letters, but you can see this one. The information or data to be communicated. It can consist of text, numbers, pictures, sounds, or videos. What is called that? The information to be communicated.
Channel.
Extended information. What's the answer?
Channel.
Channel. Channel is the medium. How you are going to? What is the things you are going to communicate? What is the medium you are using to communicate? That's the channel. Here, what's the thing you are going to communicate? It may be text, numbers, pictures, sounds, all together. We give a one name.
Message. Message.
Sorry.
Message.
Message. Message. I think that's the correct answer. We'll see it. Okay.
Message.
Yes, very good. Message. Right. Very first class under communication. Right. We are identify the elements of communication. That's the first element we identified. Message. The things. Suppose you are going to interchange. Right. Then next one. Look at the question here. The computer or device which sends the data. It can be a computer, telephone, or fax machine. We are giving one name for that. What's the name? The computer or device which sends the data.
Source.
Source. Any other answers? The station that produces or sends the data. That station may be a computer, telephone, or fax.
Channel.
Channel. Source, channel. Two answers. One sent answer through the chat box. He or she said module. Right. Actually, the most suitable one is source. Right. Source. There are many names for that. That the station which produce or start sending the data. Right. Sender or transmitter or source also correct. Right. Sender, transmitter are the correct answer. Source is also correct. Right. Next one. Look at the question here. The computer or device which receive data. That's the opposite one, the opposite of the previous question. What's
Destination.
called destination? Then what are the other names? Receiver also correct. Destination. Right. Here the answer is receiver or destination, also correct. Right. Here this one, the physical path by which data is sent from sender to receiver, such as telephone lines, fiber optics, or satellite. What is the name? Specific name given to this physical path used to send data from sender to receiver. They are giving some example for this physical path also. Telephone lines, fiber optics, satellites. All together, we giving one name for that. What is that? What the name? That we learned it today itself. We learned some part. Then last week we learned that medium. Medium. Transmission medium or medium. Right. Next question. A set of rules that governs the data communication. It represents an agreement between the communication devices. Right. Tell me anyone. Set of rules. Suggest the answer for that. I taught you this part when we discussed about the elements of the data communication. What is that?
Protocol.
Protocol. Actually, very correct. Very good. Protocol is the set of rules should follow each and every computer or device in the network. That is we identify as a part of communication system. Right. Later we'll learn in detail and examples for protocols. Okay. Next question. Data can flow in only one direction. In this mode, a sender can only send data and cannot receive it. What the mode?
Simplex transmission mode.
Simplex transmission mode. Simplex 1. Today itself we learned just before the break. Simplex mode. Very correct. Next one. Try to give an answer another student, not the same one. Data can flow in both directions, but only in one direction at a time.
Half duplex.
Half duplex, yes. Half duplex. Yeah, one student giving the answer through chat box also. That's also correct. Half duplex. This one, data can flow in both directions at the same time. It is the fastest directional mode of data communication.
Full duplex transmission.
Full duplex transmission. Full duplex transmission. Correct. This one, the example of protocol. What's the icon here? This icon represents a
Bluetooth.
protocol. Sorry?
Bluetooth.
Bluetooth icon. Right? That's very common in your phones, so in your Wi-Fi devices, normally available. This icon, that is actually type of protocol. Then later you will learn the examples for protocols. The example of medium. By looking at the picture, tell me what's the medium. What's the medium here? Yes, that one. Send the answer through the chat box. That one is correct. Another student can answer for that. Have a chance to answer it. Right? Very easy. What's the device we can see here? Earth and what's the object you can see?
Satellite.
Satellite. Then what the medium? Satellite medium. Right? Satellite. Okay, that's about some simple questions regarding the data communication. Yes, right. Okay, that's the end of our activity here. Now we'll move to our lesson. Right, write down the topic here: computer network. Computer network. Actually, computer network is a application, very big application of the data communication. Data communication define all the technical aspect of the communication path. Right? That what are the elements involved with communication? What are the rules and regulations should follow in the communication? Then what are the modes available in communication? In that way, then what are the mediums available? Those are the things we discussed. But there are more things in the data communication we should know before establish the computer network system. Actually, computer network is an application of data communication. Right? We are the part of network. Actually, we every day we are doing various types of things through the computer networks. Different types of networks available throughout the world. You are part of them. Right? When you are going to the bank, you are using the computer network. Right? Then you are study on your organization. Then you are using a part of network. Now, even now, you are join some kind of network. Right? That's why we should be able to do in this type of class even. That's the result of network. Right. Then in simple word, we can identify computer network as a collection of devices. That means digital devices. Right. Collection of or technology devices or digital devices. Right. Some examples for these digital devices may be computers, smartphones, tabs, notebook. Right. Like that, we can identify many types of digital devices in the network. Right. Especially these types of network we are established in the purpose of data sharing and communication. That these are the two important purpose why we have in computer network. The one is data sharing. The other one is communication. If you have a computer network, that means the one use is data sharing. You share your data. And if you are using computer network for your education purpose, you have many things to share with your friends or your teacher. And it may be assignment, your notes, pictures related to education. In like that, there are many things you can share through the network. That communication, that earlier we discussed that part. Communication, we need computer network to communication purposes. Right? This kind of class through the Zoom also communication. Or you can even contact your friends, your relation in remote areas through the computer network. Right? Main purpose of having this computer network are data sharing and communication. Right? This computer network that earlier I simply given a definition for that, link or create or collection of computers located in each and everywhere. Right? Then how you are going to link or create a link between these computers? Through the medium. Right? The types of medium we already discussed under data communication. Right? you can use one of the medium to connect one computer with each other. It may be a twisted line or coaxial cable or wireless media. One of the media, using this one of the media, you can connect one computer or more computers with each other. Right. Briefly, that is about the computer network. Look at the diagram here. This explains a collection of computers that connect through a particular medium. Right. Here, not mentioned that particular medium. It was probably a wire medium. Right. There are many computers around this wire or this cabling, and main computer there that later will identify the components of this type of computer network. That just for now to understand, computer network is a collection of computers that the diagram you can see, the block diagram here. You can get a simple idea of, by looking at this diagram, what is computer network. Right, okay, write down the note in left side and draw the diagram also. Right, okay. I think you finished writing this one. Please mute your video and your audio. Please mute it. Right, okay. Then that's about computer network. Now we'll see some usage of computer network. These networks are available for different purposes. Right, now we are going to identify these purpose, what is available, what are the things we can do through the computer network. And the same time, we are going to identify the particular advantage we can have in with this usage. Right. Look at the slide here. In this this topic, users of network. In this diagram, you can see two columns. The left side column is usage, then advantage. The same time, you can identify the particular advantage you can find from this usage. Right. The first one, we say file sharing. Right. File sharing, one of the main usage of the computer network. And whatever the file you are creating on your computer, it can share by others. All the people in that network are able to share in this file. Here the particular advantage is the next time when you are coming to the computer, no need to seek the same computer you created earlier, that particular file created earlier. And you can seek another computer in the network and open the file. Right? That means you can open your file anywhere in the network. Right? That's the particular advantage you can get from the file sharing. Right. Then another usage, application sharing. Then what's the difference between this file and application? File means the things you are created using some application. Right? For example, suppose word processing. Word processing is the application. That particular document you are creating through the word processing is the file. Right. Then secondly, we are discussed about this type of application sharing. Actually, when you have the usage is application sharing, the advantage is no need to install expensive application each and every computers in the network. Right. It is okay to install in the one main computer in the network. Then you can share this particular application from any other computers in the network. That's the advantage. Right. Application sharing, the application that earlier I mentioned, application means the tools you are using to create many things, many files. Right. For example, word processing is application, or spreadsheet is application, or database, MS Access is application, right? Or accounting packages. These are the application. Right? Using accounting packages, suppose you are created the profit and loss account, that's the file. Right? If you are create that profit and loss account, then it should be able to, it can be able to share by others. That's the first one, file sharing advantage. That particular application package, the accounting package, need only to install in a one main computer in the network. That anyone in the network can share that particular application. And I think you get some idea about that application sharing. Similarly, you can share the hardware also. Right? Hardware devices. That's the usage, hardware sharing. Here again, the advantage is no need to install each and every computer with that particular hardware. For example, suppose a printer and the network system having 30 computers. Suppose like that in your organization, having the 30 computers with a printer. That normally, if you have no network, that means you need separate computer for each and every computers. Separate printer for each and every computers. But if that 30 computers, suppose network, then you need only one printer. That particular printer you can install in a main computer in the network. Then others can send print out from any computer in the network. Right? That here giving some example, hardware sharing. Printer, one example, hard disk, memory, all of these are example for hardware sharing. The advantage is sufficient to install one printer or scanner for all computers. Right. I think you get some idea regarding the usage and advantages. Right. Here, write down these things. That before that we have some another set of usage and advantage also. Before moving to that sets of usage and advantages, first write down these three. Right. These are the points actually you may get your questions, your papers, right? They are most probably they are asking what are the usage, what are the advantage of network. And therefore, you need to know more usages and advantages. That is why I am discussing in some more examples for that. First, write down these three. Right, I think you finish write down these usage and advantages here. Here we learned three usage and advantages. First one, file sharing. Here the advantage is you can open your file any computer in the network. Then application sharing. Application are the tools that help you to create files. Example, word processing, spreadsheet. Here the advantage is no need to install this type of expensive software each and every computers in the network. Then thirdly, hardware sharing, that very similar to application sharing. Here also no need to install this expensive hardware for each and every computers in the network. It is okay to install in a one computer, then others can send printouts from their locations. That's hardware sharing. Right, then we'll see another set of usage and advantage under uses of network. Right. Here, first one says voice over IP. Actually, IP stands for Internet Protocol, voice over protocol. Here, the users enable to take calls, or in other words, actually taking calls through the internet. Right? That means voice data, you can send voice data through the internet protocols. That's actually advantage. That's the usage. The advantage of this usage is you can contact your relation or your friend in remote areas by low cost. Right? Normally, to get the call from here to another country or remote area, you have to spend lots of money, very expensive. But if you are trying to call through the internet, especially using this voice over internet protocol, right? Then you will make call for your relation in other countries by low cost. That's the particular advantage of here. Right. Then another usage, communication. Right? That already we know what is communication. Through the computer, this type of network system, you can send videos, text, voice. Right? Sending videos, text, voice is known as communication. That's the usage. Then the advantage is you can send high speed or low cost. Right? This type of information you can send from one location to another location in high speed. Normally we know, so think about the email, right? Then if you are sending the email from your location, then how many seconds taken to get it in the destination, right? Destination may be another country, the other end of the world, but few seconds you can complete